so I sometimes I'll move to pad, writing pad, or sometimes on the PPT. Okay, fine.
Yes.
Oh, okay. Thank you, Lakshit. So the screen is visible, na?
Yes, sir.
Okay, fine. Okay. Okay, so good afternoon to all of you. And today we are going to start our second unit that we have talked about the all of the basic contents related to our subject in unit 1. So now you can call the second unit even or whatever, because I have divided all the contents in different units. And the second unit, as you can see here, it is having many topics, the basic topics like model for security, then cryptography, then authentication key establishment, message authentication codes, cryptographic hash function, DOS attack, and spoofing and sniffing attacks, and all. Other than this, we are also having some kind of the fillers topic like modular arithmetic, concept of modular arithmetic, and we can say some kind of the cryptographic techniques we will also discuss. So these all the contents that you can see in second unit. So I thought that I think that it will take 10 to 12 lectures. So within the 10 to 12 lectures we will going to finish this complete thing. Okay, so now we will start. Although there are 13 students, but still we can start. It's Lakshit, it's okay, fine.
Yes, sir.
Okay, fine. Okay, so here you can see a model for network security. Fine. So for discussing the complete thing, I'm just putting glassboard here, and before putting the glassboard, I have to, I think, I'm going to share now. Okay. Okay, Lakshit, now you can see the glassboard.
Yes, sir. It is visible.
Okay, fine. So I'm now starting. I'm now starting the write something. So if there will be any issue, so please tell me.
Sure, sir.
Okay. 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 When we talk about the any kind of the model of security or network security, then very first thing that you can say here, that is message, or in general we call it the plain text. This is the terminology that we use. That is nothing but plain text. And this is the secret information thing that you can see here. If we are doing any kind of the substitution, or we can say any kind of the algorithm, right now I'm not talking about such kind of the model that is having any kind of the encryption and decryption, but this secret information you may include that it is nothing but kind of the encryption scheme or encryption scheme, or similarly at here we can say that this is decryption scheme. We will discuss what kind of these schemes are available. So actually ये admit का बड़ा issue है. Just wait. Okay, so once we have applied any kind of the encryption scheme, then we will get the secure message, and this secure message we can call ciphertext. Nothing but ciphertext. Whatever I'm writing, it is visible.
Yes, sir.
Okay, fine. Okay. In between, I have to admit to the students that that's why there is interruption. Na? So I request to all of you, please join the meeting at the particular time. So then our lecture session will smoothly we can conduct. Okay. So another thing, that is trusted third party or the distributor of secret information. So we can say, if we are considering secret information is nothing but a kind of key, we will see the concept of key and all. So this is the provider of key. We can consider here. In general, if we can take the example of like net services, internet services. So this third party distributor, maybe if you are using at home the BSNL or the Airtel or whatever the Wi-Fi modem, so that company you may consider as a third party, because they also provide the secure kind of the things. So but here in general case, the third party or distributor we may consider as the provider of the key for the both side, in at the transmitting side and at the receiving side, so for encryption purpose and decryption purpose. Now this is the information channel. So this is the crucial thing, this one. Why I am saying, because any kind of the attack, if we will consider here opponent, for your easiness we can consider that this is opponent is nothing but kind of the, if you use a word hacker, if you want to use, then you can also use, otherwise hacker, or we may say this is nothing but intruder. So any kind of the attack, most of the, or we can say the most of the attacks are tried to launch in the information channel, because after doing or after converting the ciphertext, so when ciphertext move to the information channel via wireless or wired, so uh, here detection or detecting a message is easier than the than at the other part. And the same thing, once at the this complete thing we may consider at the receiving end. Fine. So this is the uh, secure message that you have received, or the ciphertext, and the decryption algorithm, it is nothing but the dual, we can say, not exactly dual, but we can say the alter case of encryption. Whatever the encryption scheme we have applied for doing the encryption, we just apply the alter case at the receiving side and get the message back. So here we will get back our message in form of plain text. So this is the general concept of uh, network security model. Okay, now we are talking about the basic terminologies here. So I'm using this pad. Okay, so plain text, if we will say that plain text or simply the PT, so it is nothing but a raw data message, or simply a raw data that we want to send. Similarly, ciphertext, I'm writing in short. Ciphertext is the converted message, or we can say converted plain text, even converted plain text. So with key, then encryption is encryption. Don't worry, I'll do it fastly because I know that you all are aware of all these basic things. So when we say encryption, so this is kind of the method by which we convert ciphertext. This is kind of a logic, we can say, in one sentence, kind of a logic by which we convert the ciphertext from message plain text. So if we say that message we are denoting with capital M, so any encryption, if we are using a E word for E letter for encryption, then encryption is the algorithm is applied on message and along with a key. So this is, or more simply, we may write like encryption is applied on message along with key. With, and what is the logic? The logic is defined with the encryption algorithm. The similar thing we may talk about the decryption. So for decryption, this is again, as I told you, that it is nothing but kind of the reverse logic of encryption. So if we are using a letter D for decryption, then we may say that it will apply on ciphertext whatever the encrypted version we are having here. So I am simply writing the ciphertext and the key. I am writing with the same color to the key. It means the same key we are using for encryption as well as decryption purpose, and such kind of the logic or technique is called symmetric encryption key scheme. Other than this, there is another kind of the key scheme that we will also discuss in later section, in later lecture sessions, that is called public key scheme, in which a pair of key is used, one key for encryption purpose and another key is used for decryption purpose. Now the most important thing, now I'm writing here, that is crypt analyst. Crypt analysis. Okay, now crypt analysis or the crypt analyst. So don't get confused. This word is always not a bad word, means always we cannot use this word for any kind of the intruder only or the opponent only, but sometimes we also try to find uh, a logic, also try to find set of plain text or set of keys with the permission of administrator within the system. So cryptanalysis or cryptanalyst is kind of, if we talk about the cryptanalyst, then it is kind of a person who try to detect, who try to detect, try to detect plain text, generated plain text, definitely, even ciphertext, and sometimes key also. So generally, it looks that this is these are the activities of intruder or opponent only, but sometimes we also require to do these things for checking or uh, for improving our systems if we will face any problem. So these are the basic terminologies that we will use throughout this subject. Okay, so we can say In short, that plain text, it is actual text, this one. Similarly, ciphertext, as I told you, that encoded text or data. Now, key is the secure code. Okay, we have not discussed about the key, but in the next slide, we will talk about this key. So key is the secure code that is used for doing the encryption as well as decryption. Then the cryptanalysis is nothing but study of decoding the codes, as I told you. So this codes word, it can include plain text, ciphertext, or the pairs of key. And at the end, there is one word that is called cryptology. So this is nothing but study of both theories, like cryptography. Basically, when we talk about the cryptography, so it is the this is the Greek word crypt and graphy. So basically, the kind of the logic or kind of the theory by which we can hide our data. So simply, this is the cryptography. And cryptanalysis and cryptography, someone who is studying both the things, then it is called the cryptology. Okay, so these are the basic terminologies that we will use. After that, okay, so now I'm talking about the two different techniques. Okay, I'm not reading out all these things, fine. So because you are the final year students, I'm saying this thing again and again. So I'm not reading out, I'm just telling to the basic or main concept about the topic. So again, I'm putting the glass board here. It is on. uh, it is okay, it is visible, Lakshit?
Yes, sir.
Okay, fine. Okay, so when we talk about the symmetric encryption, so it means the same key. I'm simply writing here the same key is used for encryption and decryption purpose. We can say, means we will use the same key. So this is conventional encryption scheme. We will see how it works in the next slide even. And it is also called private key encryption method, this one. So this is called the private key encryption method. It is also a conventional method because when the cryptographic techniques and encryption techniques was introduced in the past, so this symmetric encryption was introduced in the starting. So this is conventional and private key encryption, and basic logic is this, the same key. Now in asymmetric encryption, as we know that today we are having the word of digital world, we are using, everyone is using internet. Even we are we are talking about, we are taking the lecture sessions with the help of internet. So easy accessibility of internet due to this. And so with this, I'm just telling to you that requirement of internet has been increased, and simultaneously the requirement of public key encryption, because this is also called asymmetric key, is also called public key encryption technique. So this is also called the public key encryption technique, and due to the requirements, this public key encryption technique uh, is now the need of today's world. Okay, so here what happens, here the pair of keys, even we can say pair of keys is used. And what kind of the pair? That is, we call it pu, let's say a, and p r a. So what it means, this is called the public key. This one is called the uh, this is called a public key, of user A. Now this is called the private key, of user A. Now this is called a key pair, public key and private key. And these pair definitely will be generated with the logic only, because we are going to use for encryption, means for sending end. If we are using public key of user A, then at the receiving end we must have to use private key of A only then we can get back the message. So this is the logical pair, as I'm telling to you. We can take an example. Suppose we are having PUA and PRA, and let's say I'm writing on top PUA and PRA. Similarly, PUB and PRB. So I don't think there will be requirement of writing each and everything. PUA is the public key of user A, PRA is the private key of user A. Similarly, PUB is the public key of user B, and PRB is the private key of user B. So if we are doing encryption at sending end, suppose let's say with PUA. Okay, so at the receiving end, we, for doing the decryption, for getting the message back, so we require only PRA here. We cannot use PRB, we cannot use even PUB. Okay, so that's why I'm calling the logical pair every time, and we use these keys, public and private keys, in pair, in pair with logic. Okay, so it is mentioned here that it is a kind of encryption scheme where different pair of keys called as public and private keys used. So we will, again, I'll tell you that we will discuss in a different lecture session about the public key cryptography, because it is the requirement of today's. Okay, now we can move to the another slide. If anyone wants to ask even in between, he or she may raise the hand. Okay, so if anyone can ask, then he or she can ask, because topics are going on. Okay, okay, just wait. Okay, so in the next slide, now we are having symmetric cipher model. Okay, so as I told you, in symmetric case, the same key. So this is the same key we are using. Just wait. Okay. Same key that we, it is visible na, same key abhi maine likha, Lakshit.
Yes, sir.
Okay, fine. So just using the different color now. Okay, the same key. This one. Both are the same key. Okay, it means this is symmetric cipher model, and whatever we have discussed in very first slide, that secret information. So this is the secret information. So that was the generalized that was a generalized slide or generalized network security model. So this is secret information we can consider, and the same thing, the secret information we can consider to this also, that will generate a key. And this is the logic encryption algorithm, and here we are taking one example, DES. So this is nothing but data encryption standard. Even though we have to discuss this, as you have seen the experiment list, so this is also mentioned in that list. Okay, so this is plain text, say M, message M, going to encryption algorithm. This encryption algorithm converted to the ciphertext. Here ciphertext is here, then it is with the help of key, and it is it will transmit to the receiving side, and for the decryption algorithm, this will be the input. This is the input. Ciphertext will be the input, and with the help of key, so we can say like this, T K, and this decryption algorithm is applied on ciphertext, and now we are getting back our message. And similarly, the mathematics we can write here, that here the for generating the ciphertext means encryption will be done with the help of the same key, and encryption key will be applied to message M. So with this simple logic, we will do the uh, symmetric cipher modeling. Okay, so now this is the actual mathematical diagram. Okay, so for discussing this, what I am doing, that screen capture. Okay, so just wait for a few moments. I'm just capturing this complete thing. Just wait. Okay, it is visible.
Yes, sir.
This uh, this diagram. Okay. Okay, this is the general diagram. Here, all of the things that we are using a letter X for message. So we can say that this is in form of vector. So we can say that nothing but x1, x2, x3 dot dot dot. Let's say xm. Okay. So because now we have to develop the um, mathematics of each step. That's why uh, this diagram is very important. So this X is kind of the vector set. It may have the bits, data bits, or the message in form of the letters. Okay. Now similarly, Y is the encrypted thing. So we can write Y something like this. Again a vector case, like Y1, Y2 dot dot dot. Let's say ym. Not m, we can use another initial for this. Okay, let's say yj. Okay, so logic is applied with the help of key, and now the key source. This is, you can consider a key source as a distributor of secret information. Distributor of secret information. Fine. So again, we may also consider K another vector set, and it is having nothing but K1, K2, dot dot dot. Let's say KQ, whatever the initial. The key vector set. Now this is the message vector set, this is key vector set, and this is the ciphertext vector set. And what the logic we are considering here, that for generating the Y1, we are using encryption algorithm. Here is nothing but the DES, and for generating Y1, we are applying K1 on X1. Similarly, for generating Y2, we are applying K2 for generating K2 on message X2. Similarly, we may write like for generating jth ciphertext bit or letter. Remember one thing, generally we use the in form of data bits, but some we also use the letters. Okay, so encryption with the help of, let's say, qth key, and we are applying the same logic on, let's say, x of n, xn. So this is the general concept, and at that decryption algorithm, the same thing we try to get back with the help of the reverse logic of DES, reverse logic of DES. Okay, and this key will be sent by a secure channel. This is I'm writing because once our key will get compromised, then our whole system will be compromised, and security will be breached easily. So this, for sending the key, we use kind of the different secure channel other than this channel by which we are transmitting the ciphertext. Okay, so and we get the message back with the same logic as we have discussed here. Now the important thing is the cryptanalyst, and this is called the estimated values of x, and this is called the estimated values of key k. So now what is the meaning of this estimated values? As I told you that to the cryptanalyst, if you are considering that this is nothing but the opponent or intruder, the someone who wants to breach the security. Fine. So what is the requirement for the launching the attacks or for getting the messages from the channel from here? Okay, so this one. So the knowledge of, sometimes the cryptanalyst attack will depend on the knowledge of generated plain text only. So then this is hit and trial method. Then once this cryptanalyst is having the knowledge or is having the different pairs of plain text, then this cryptanalyst will try to mm, uh, will try to generate or will try to predict even that what will be the next plain text that will be generated by the system. So let's say if cryptanalyst is having x1, x2, x3, then he or she will try to predict about the x5 or x6. So with the help of this estimated thing, cryptanalyst will try to predict or try to get the x5 and x6 message. Similarly, the more dangerous cryptanalyst attack that will be launched that if any cryptanalyst, if having the knowledge somehow, let's say suppose somehow he or she is having the knowledge about k1 k2, let's say k3, the estimated value, now he or she will try to predict the next key, say k4 or k6, something like this. So this is the very important thing that we have to handle when we try to generate a simple network security model. And another thing, if you are getting confused with the help of different keys, this is again a symmetric key encryption method. Don't get confused that if we are having the key, different keys are using here. No, what we are doing, that we are using k1 for generating the x1. Now the same k1 will be used at here for generating revert back to the x1 itself. So this is simply a symmetric key system, not a asymmetric one. We are not talking about it. Okay, okay, fine. So now I'm closing this screen and going back to the normal screen. Okay, now this is the diagram that we have talked about. Each and every aspects of this diagram we have discussed about the secure channel even. So this is, when we talk about the secure channel, so this is a very big issue, big challenge, that using the symmetric key encryption, that we have to use two different channels, this one and this one. So two different channels we have to use, and this is costly thing, but definitely it will provide the security. Two different channels we are using, but it provide the security also. So this is the simple conventional crypto system. Okay, then we move to the next slide. Okay, just wait. Okay, okay, I think now this, that whatever we have discussed, it is written here, and after that I have to talk about these two attacks, but now time is running out, because next this the same license will be used by another faculty. Okay, so within, for the 2 to 3 minutes, I will continue this topic with this cryptanalysis topic, and the attacks. We have to talk about the attacks even. Okay, so I'm stopping this sharing. Fine. And if anyone is having Lakshit, it is okay.
Yes, sir.
So whatever I wrote, everything was visible, na?
Yes, sir.
Okay, fine. So anyone is having any doubt or anything, then he or she may raise the hand, because for we are having only 2 to 3 minutes right now. Even for doing that discussion about the queries, we will have the separate lecture session for the queries even. We can do this practice also. So if anyone is having any query, otherwise I will end this meeting. Anyone is having? No. Okay, fine. So thank you very much. Lakshit, especially thank you.
Thank you, sir.
Okay, so I'm ending this meeting, and we'll continue the same topic tomorrow. Okay, thank you.
Okay.